Have you gotten by now? Okay, you bought. So, how much you buy? Huh? Seconds left. 31 to 40. It's your work. Yeah, please be careful. Okay, 31 now. Now imagine this is your JAMB question. You shouldn't be missing. If you're going to miss any question from 1 to 10, it shouldn't be more than 1. Yes, it should be more than 1. All topics now. It's too late to be missing many questions. Missing out of 10, you miss 5. That's too much. 31. When the TH is negative, the reaction is said to be what? Exothermic. I don't know. 1 out of 1. 32. See, this material came out in your mock that you did maybe in February or so. But most textbooks miss the question, including many answers they provided online. And I'm sure some of the answer they may likely give you may likely be the wrong answer too. May likely. As the concentration of an electrolyte reduces. Now, what is the meaning of concentration? And define concentration for me. What is the meaning of concentration? Number of moles of a solute that is present in 1 dm cube of a solution is called concentration. Now, when you are talking about as the concentration of electrolyte reduces, what does that mean? That means the number of moles of a solute in 1 dm cube is very small. It's not very small. And then the charge carriers are those number of moles of solute. They are the charge carrier, the ionic concentration are the charge carriers. So when you reduce the concentration, then invariably what should happen is that the conductivity should also reduce. That should have been the answer. But officially, yes, that's what the old textbook, even on Google, if you Google it now, that's what they want to write down for you. But that is not totally correct in science. That's realistic. But for you, let me not try to break table. Let me just leave it like that, break leg. So that's what many people will pick. But officially, that's not right. So as conductivity of the electrolyte reduces, conductivity reduces. So I can give you B. It's okay. But as we're going advanced in university, you will observe that when the concentration is reduced, what does that mean? That means the moles are now very small. Number of moles of the solute are very small. We call it sparse, S-P-A-R-S-E. And then when current now want to flow, it is now easier for current to flow because it has few molecules. However, when the molecules are very many, you know, and then current want to pass. You know, this is talking about molecular theory now. But as for your level, you can see mark it for you like that. Now, if you now have many, this is concentrated solid now, solution. Highly concentrated, so many large number of moles of solute. Class, look at this one and this one. If something want to pass here, something want to pass in between, and something want to, let's say this is A and this is B. If something want to pass like this, and that one want to pass here, which one do you think will be easier for something to pass? That's exactly the story. When the conductivity, when the concentration is very small, conductivity should be very high, because current should be able to flow easily. That's physics explanation. In physics, that's the perfect one. As the conductivity is, as the concentration is reduced, it should be easier for current to flow easily. You know, it will be difficult for current to flow here now. You can see it is compact, large amount of solutes in one DM cube. But do you know the explanation for chemistry? Explanation for chemistry, why this one may be a bit right, is that in chemistry, what is responsible for your conductivity? The charge carrier, okay, let me use this way. The charge carriers in electrolyte are called what? Hydrated ions. And this one is having more ions. And because having more ions, the number of charge carriers here are higher than the number of charge carriers here. So a highly concentrated solution will have a higher conductivity. You know, so it's very correct. So I will still give it that decreases. It's okay. It's okay. Decreases is still okay. Yeah, but if it is physics, then we have to change it to this one now because of mobility. Or chemistry is still chemistry. So the answer is decreases. Let me leave it like that for you. Decreases. So what if we say it in physics? Then we have to reverse it. Yeah, that's the word. But you won't see that in physics because that's not physics question. So in chemistry, that's what you have stored in your head. The higher the concentration, the higher the conductivity. The lower the concentration, the lower the conductivity. So it's correct. So let's pick B. Right, everybody, right. Notes. Conductivity increases. Conductivity increases with concentration. Conductivity increases with concentration. Because the charge carriers, conductivity increases with concentration. Because the charge carriers are higher. Because the charge carriers are higher. Conductivity increases with concentration because the charge carriers are higher. Full stop. I think that should be clear. So the higher the concentration, the higher the conductivity. Because what is responsible for that conductivity are the charge carriers. You may see one or two textbooks that may say it otherwise, reasoning the way I'm reasoning now, you know, but let's still stick to this one. This one is still better for chemistry, better. Let's go 23 now. In which of the following reactions has the oxidation number of nitrogen increased? Listen to me. You are never increased when on the left you are NO. Or right, you still get NO inside you. See right, NO. There's no increase there. NO there, NO there. That's how to do it. Look at option C. NO there for left. Can you see the option C? Inside option C for right, what do you have? There's NO in bracket. Can you see that? So there's no change. If you go to D, NO there. And you see have NOCl again. NO. Can you see? No change. So the answer should be what now? D. You have NO, now turn to NO2. Nitrogen 2 oxide, now turn to nitrogen 4. You don't have to start calculating one by one. NO on the left, NO on the right, no change. NO on the left, NO on the right, no change. No. The other one is now NO2. That's it. 34. I've answered this one last week. Ammonia gas plus HCl gas can't give us solid. When gas turns to solid, entropy, has it increased or reduced? Reduced. The entropy change in the system above is what? negative. It has reduced from gas to solid. Gases, they are everywhere. Solid, they are orderly. 35. Fermentation is what? In of carbohydrate to glucose. Is that correct? Never. Fatty sugar to alcohol. The answer is B. B. Some people call that anaerobic what? Respiration. There's no oxygen involvement. The sugar will just break down and give us ethanol and carbon dioxide. Class, they can ask you in the exam, what is the gaseous product obtained from fermentation process? CO2. Note it down. The gaseous product in a fermentation reaction is CO2. The gaseous product in a fermentation reaction is CO2. The gaseous product in a fermentation reaction is CO2. Gaseous product in a fermentation reaction is CO2. Let me even give you the reaction. So now glucose is the breakdown, not the 6,6,H12O6. The enzyme you need is zymase. It's what class? That's the enzyme needed. And you are going to have ethanol, what we call akweteshi, or kain or resi, taju, maribo takedo, or pain. They have so many names. It's the commonest product in Africa. Looking about to 4 and then 2 here, I think. 2 carbon. 10, 12, oxygen 6. That's it. So this is ethanol. And that's CO2. So they can ask you in the exam, the product obtained, the gaseous product is CO2. While the liquid product is what? Ethanol. Well, let's go to the next one. Number 36. It must just taught you. What is the functional group for alkana? Functional group for alkana. Is that functional group? CHO. Functional group is CHO. Alkana, yes, no anything. I'm not asking for the general formula. There's a functional group for alkana. So the answer will be RCHO. RCHO. Class, what class of compound is ROH? So CO. Ketones are unknown. How to CO? RCOR prime are unknown or esters. Have you? All of you missed 37. I'm mainly impurity in iron, Mr. Victor has taught you. Impurity in iron, the extraction of iron. If you take calcium trioxosilicate 4, you are wrong. That's not the impurity. That is a waste product that is obtained from the impurity. The impurity is silicon 4. That's it. A. Silicon 4 oxide. But when they ask you, what is a byproduct in the production of iron or extraction of iron, the answer will now be calcium trioxosilicate 4. So see, we need limestone there. Limestone will give us calcium oxide or CO2. So this one will now combine with the earthly impurity. The earthly impurity is silicon 4 oxide. It's now what we call slag, isn't it? This is a slag, calcium trioxosilicate 4. But this is the impurity that is there. So, I have not been taught, okay, you have been taught sulfur. During the vulcanization of rubber, sulfur is added to. Now, let me show you. The major component of rubber is isoprene. It's what class? Isoprene. And that isoprene is what? 2-methyl butyl 1,3-diene. Says 2-methyl butyl 1,3-diene. Again, 2 methyl one 3 diene. That's isoprene. This isoprene is for natural rubber. For what class? What is the major one for artificial rubber? Neoprene. What is neoprene? Styrene, butadiene rubber. Uh, so this is isoprene. Now, let me draw the structure for you, and then I will now show you why we need to vulcanize. Mr. Michael, please check our screen. It's doing blah, 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 blah. Buta, how many carbon is buta? So, 1 3 diene. What does that mean? Is it still okay? It's okay, Abby. Okay. Double bond on carbon 1, double bond on. So you can put it a double bond. So it is 1, 2, 3, 4. Double bond on carbon 1, double bond on carbon 3. Then others, then 2 methyl, another methyl there. That's it. Thank you. So that's 2 methyl. So all of them now, this hydrogen. This is already 4. Maybe hydrogen here. Then this hydrogen. This, the guy, the isoprene. Now, this is not, there are so many spaces everywhere. The guy has spaces. What does that mean? There's no linkage. That's the word. There's no linkage. There are spaces. So what do? We now vulcanize. We add sulfur. But then we add sulfur, what will happen? All the double bond will now be broken. We have something like this. H, C, the C here, H here rather. Then sulfur will now be here. Sulfur, carbon H, another sulfur. We now have C, CH3. We now have another sulfur. We now have C, H, H. Maybe another sulfur here and H. So here before there are spaces, there are spaces. But then you now put your sulfur, that will now increase the linkage, we call it increase the cross linkage of that guy. It will bind them together. That's the word. They're now closer together. Unlike all these spaces are now filled. So let me look at the answer. Break down rubber polymer. No. Lengthen the chain of rubber. Lie. The length in anything. And then C. And rubber molecules together. Right. Note again. We're just doing revision. Notes. Sulfur help to increase. Sulfur help to increase the cross linkage. Sulfur help to increase the cross linkage in the rubber molecules. Sulfur help to increase the cross linkage in the rubber molecules. Sulfur helps to increase the cross linkage in the rubber molecule, hence making it stronger and tougher. 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 I see that. 39. If you listen in class today, he must taught you this. I never knew I'm going to give you this question. I didn't know I'm going to give you this question. So that's why you have to listen in class. He explained that benzene undergoes substitution. The only time you can undergo addition, most times, is when this happens at the junction of benzene. And that will give us cyclo. The answer is B. Abi. C. Cyclohexane. Cyclohexane. Is cyclohexane there? Okay. Number 40. A triadic canal what is what we're going to teach you? The functional group in a canal. Look up, see a canal. First one, these are the classes. We have monohydric. This is dihydric. This one polyhydric. May not even be polyhydric or trihydric. We have not seen the one with 4. I think trihydric. Monohydric also, they have 3 types. We have primary, secondary, and tertiary. Primary, secondary. Now, this monohydric, they have only one H group. They have only one OH. The one I just gave you today now, that ethanol, C2H5OH, it has only one, so it's called monohydric. There's some guy that has double, like this guy now, CH2OH, CH2OH, it has 2. Yeah, when you have 2 carbon atoms, what's your name? Ethaway. So I can call this one ethane 1,2-diol, because it has 2, or ethane 1,2-diol. That's it. It has 2 OH. That's called dihydric. And this guy is called glycol. It's got what class? So when you have, that's glycol. That's general formula for glycol. You have 2 OH. Now, polarity like tetra, you can have more than 2, like this one, CHOH, and you can have CH2OH, you know. Like when you have 3 carbon atoms, what's your name? So I can say propane 1,2,3-triol, or propane. So let me call it propane 1,2,3-triol. It's also called glycerol. It's called what? Glycerol. That's it. So when you have more than 1 OH, then you are polyhydric. You know. So this primary, they're like this. RCH2OH. That's their general formula. This one, RCH prime OH. This one, R prime prime OH. Maybe I will draw this one very well. R C R H OH. So I've given you all the type of ethanol we have. No, only one. If you are primary ethanol, link to the grammar. The carbon having the OH must have 2 hydrogen atoms. I repeat that. The carbon having the OH must have 2 hydrogen atoms. If you are secondary ethanol, the carbon having the OH must have 1 hydrogen atom. Only one. If you are tertiary, the carbon having the OH must have no hydrogen. No hydrogen. This one, 2 hydrogen. This one, 1 hydrogen. This one, no hydrogen. You'll see question very soon. No? This one, carbon having OH must have 2 hydrogen. Carbon having OH must have 1 hydrogen. Carbon having OH must have no hydrogen. Another way of saying it, carbon having OH must have 1 alkyl group. Carbon having OH must have 2 alkyl groups. Carbon having OH must have 3 alkyl groups. I'm going to answer one of the question now. So if you go back to the question, a triadic ethanol, I mean, the answer is glycerol. I agree. The answer is A. A. Yeah, let me ask you whether you can identify some things. Let me ask you if you have, you will show me whether this guy is primary ethanol or secondary, as a drawing, or tertiary. Look at this compound, CH2, CHOH, CH2, CH3. This CH3. Another one, CH3, 3, OH. Something like this. C, OH. Another one, CH3, CH2, 4, OH. So what are we doing? Tell me whether this is primary, secondary, or tertiary. This one, primary, secondary, or tertiary. This one, primary, secondary, or tertiary. That's number one. Number two, name the compound. 10 seconds. Ah, is it? What do you mean when I was thinking? Ah, no wonder. I didn't see it. They all run up notes. I've never seen like a phone before. This class, this place, and that's last year now. Well, are you okay? I'm sure you did very well this time. Exam has come on. Junior cannot see the board. Anyone true? Maybe you should name them first if you cannot identify. It's not yet true. Okay, yeah, true. What's the first compound? What about alkanol is it? Okay, let's go to the first one. Because we're not just answering questions, we're revising. It's not just rushing the 50 questions, then we'll go home. No, that's not the goal. See the first one, CH3. You can even draw it out. You can put the OH here, then put the H here, then put the CH2, CH3. If you want to name it, you can just say, because the OH is there, start 1, 2, 3, 4. You have OH, your name must end with all. So don't go and say butane, no. Or you have 4, you can say butane. Now, the OH is of carbon 2, and it is 4 buts. So you can say butan 2 all. That's the name. Some old school can say 2 butanol, no problem. Can manage it. 2 butanol. Ere, are you okay? Are you getting it? And 2 all, 2 butanol. What type of alkanoid is this one, class? Is it primary, secondary, or tertiary? Secondary. So how do they know it's secondary? The carbon having the OH must have only one hydrogen. That's it. You can even write it like that, the way you can understand. For secondary, the carbon having OH must have one carbon. That's it. Don't be lazy to jot down points. The carbon having OH must have only one hydrogen. No, this one is not the hydrogen. This one belongs to this carbon. So the only one he gets, that's it. So this one is secondary. Class, let me show you something again. See this carbon here. This carbon. Look up. This carbon. This carbon has 4 different things surrounding it. Can you see that? See, 4 different things. CH3. What is here? What is here? What is here? CH2, CH3. I'm not complicating. Anytime a carbon has four different things surrounding it, that carbon is called a chiral carbon. It's called what? If you want to talk. Chiral. Mr. What does that mean? That means that compound can undergo optical isomerism. Can undergo what? Once you have four different things surrounding you, you can give you an example. The following can undergo optical isomerism. That's what they're asking for. The one that has a carbon that has four different things surrounding it. That's called chiral carbon center. And because you have four different things surrounding you, you can undergo optical isomerism. I'm just trying to see what I can. I'm just trying to assist, support your teacher for chemistry because you may not finish things as time is going. And so we may need to jot down. If you are waiting for notes from him, it's not bad. Wait very well. Oh. Yeah, it's not bad, but just want to sit down. You can learn them before he teaches you. That's it too. I've explained so many things on that one now. Let's go to carbon second compound. What's that one? So don't say this one doesn't exist. You draw it out. So you have CH3 here. See, there are three methyls surrounding the guy. So you put another CH3 here. They don't want to tempt you. Another CH3 here. That's the meaning. Not trimethyl. Trimethyl. Methanol F9. Methanol call. Trimethyl. You draw it out like this. 3 methyl upper 1, 2, 3. Now put the OH here. Class, how many hydrogen? This is the carbon having the OH. Sure, you know. Carbon having OH. How many hydrogen is bonded to it? No hydrogen. No hydrogen. And when you have no hydrogen bonded to you, what type of alkanol are you? Tertiary. 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 Or you have 1, 2, 3. 3 alkyl group. That means it's tertiary. What do you know of this compound? Who can tell me the name? So methyl. This is methyl, are we? 1, 2, 2 methyl. See, I hate it. Learn. Learn. You can't be hating anything now. Exam has come. Learn it. So the guy is secondary. This one is secondary, are we? Secondary. Look at this one here. Tertiary. All right, the last one. That one. This one. Don't want to say 4, 5. They don't teach us 5. It's like CH3. This one here. CH2. But I want you to be able to draw it. CH2. 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 OH. Guy, people put them H, H, OH. That's all. See, this CH3. Then there are 4 of them. 1, 2, 3, 4. That's the meaning. So if you are confused, draw it out. Let me give you the name. 1, 2, 4, 5. Demonstration. 5. So what's your name? 1. Oh. But why is on carbon 1? Pentanol. Type of alkanol. Secondary or tertiary? Primary. So why? The carbon having OH has 2 hydrogen atoms. You go to your past, you see all these things here. Primary, tertiary, secondary. And you're knowing whether it is primary or secondary or tertiary will also tell you the product you are going to get from them when they undergo oxidation. When they undergo what? Primary alkanol, they will give us alkanoic acid. But if it is incomplete oxidation, you get alkanal. Secondary oxidation will give you alkanone. Tertiary will never undergo oxidation. You'll see learn more later. Let's go. Number 1 to 10 quickly. 1 to 10. Jiro Masun. That one is sleeping. to 10. Precious. I don't get question. You go governor. If you collect money, you don't get one to buy. No, I'm talking to her. Very good. Abula, where's Fidaus? Sekinango. They've not come. They're enjoying is it Dil Mubarak now? Nancy is not here and Aleke. They never come. Please don't be tired. Do it as if you are doing exam. Don't say I'm tired. Don't be waiting for correction. Sam, Samuel, Samuel Andrew Bassi. Your mom is waiting for you outside. Samuel Andrew Bassi. To be true by now. Okay, let's go through. Number one, if the gas is cooled, at what temperature will it start to condense? Condensation is what? The process of converting what to what? Vapor to liquid. So the gas will start. Here's the gram. Can you see that? This method is what we call the change of state, as we said in the morning. There will no change in temperature. Here, change of states. So these are vapor. These are liquid. This is solid. This is when the solid starts melting and it finish melting here, turn to liquid. When it's going to start vaporizing and it stop vaporizing here, it's now vapor. So they're asking you, at what temperature will it start to condense? So the answer is this temperature. Have you? This temperature here. Condense means to turn from vapor to liquid. So yeah. So if you have 200, yeah. 100, yeah. The middle are 150, are we? The other will be 150. The middle of the two. Just use your eyes. You don't need to go and start drawing line. That's not the question. It's not the middle. It's not three division. We have three division. One, two. Is it not three division you have? Now three division now. Division, we have 1, 2, 3. So the middle, that is 150. Not 175, 150. Now three division there. But it's close to 200. Eh? This one is not 200. This is 200, yeah. This is 100, yeah. So what is it? So the answer is 150. The class, how long does it take all the solid to melt? They started melting it from here. They started applying it from here. And it finished melting. Yeah. This when it finished melting. Oh. So from here to here, how much? That's the answer, 2.5 minutes. Yeah, it has not started melting, no. This one started melting. So all this time, we're going to add all the time. But they ask you to find the time taking for the time taken for the melting process only. That'll be from here to here, but they're not asking for that. You know, and that will not even be there. And some of you means the first two questions, oh, you are saying double. That's the danger of hunger. You need to see well. Amaka cannot see well now. She's hungry. 25 cm of a gas X contains Z molecules at 15 and 75 millimeter mercury. How many molecules with 25 cm? Look at that word. The same volume, Abby. Avogadro's law ló sọ wípé equal volume of all gases at the same temperature. Contain what? Contain the same number. Again, Avogadro. Sink equal volume of all gases at the same temperature. That's rubbish. Contain the same number. Stop. That's Avogadro's law. That means when you have the same 25 cm cube, 25 cm cube, the answer is Z. Z, don't go and be writing rubbish. You have the same number of molecules, ZZ. The first three is on book 0 over 3. You're going to smile, small. Now 4, what mass of water is produced when 8 grams of hydrogen react with excess oxygen? Now, when you see the word excess oxygen, we're not concerned about the value of that oxygen. It's water. So balance the equation. I think now this is 2, including 2, 1 times 2 now 2. 4. This one 2, 18, 36. Is that correct? So 4 give us 36 before starts the reaction. Are we given 8? So that's another 72. That's the answer. 4 is 8 times 36. Otherwise, to be 8 times 36 all over 4. 4 here, 1 here, 2. What's the answer? 72 grams per mole. Gram. 5. A particle that contains 9 protons, 10 neutrons, and 10 electrons. Which one is more? Is it the proton or the electron? 9 proton, 10 electron. Look up. Naturally speaking, for us to be electrically neutral, we should have the same thing. Naturally speaking. in atomic level, we must have the same thing. Now, electron is now more than the proton. What does that mean? Have I gained electron or I've lost electron? I've gained, because the electron is more than this. And when you gain electron, are you positive or negative? Negative. Negative ion. Negative ion. So that's why it's A or B. Cancerous growth are cured by exposure to what? Gamma ray called X-ray. If they taught you chemistry is wrong. X-ray. Gamma ray will destroy your cells. Gamma ray will destroy your cell, will destroy your tissue. Don't try it. If you talk like that, you better debunk it from your head. X-ray. And the X-ray is not ordinary X-ray. They are what? Soft X-ray. Don't want to use gamma ray. You could die. Right. Number 7. Gamma rays are dangerous. They have very high frequency. And they have extremely short wavelength. They are dangerous. Infrared X-ray are also dangerous, but we have soft X-ray that can be used. Number 7, an oxide SO2 has a vapor density of 32. If your vapor density is 32, what is your molecular mass? 64. So people want to do 32. You go get 0 for S. 64, have you? So now X plus 32 equals 64. X is 32, have you? Can you see? 32. Contribution to the development of the atomic theory is the determination of what? Charge on electron. The answer is A. Help to determine charge to mass ratio. J.J. Thomson. Thomson. 4 elements W, X, Y, and Z have atomic number 2, 6, 16, and 20. Which of those elements is a metal? For you to be a metal, you must either have 1 electron in your valence shell or 2. Alkaline metal, alkaline earth metal. We don't even like all those group 3 elements as metal. So the answer is D. That's Z that we. Z is C. 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 That's it. 2882. That's calcium. Have you now? This is number 10. We've done it before in class. See, some people have so much read that number 10, it didn't work. They just pick answer. We've done this one before. I know the answer. I remember it. That's the level of great reading. Oh, yeah. 116 plus what? That's what? It was how much? 16.2, I mean. It's up to 8.4. 8.4 plus 0.1 m equals 16.2. Can use any method you like. 0.1 m, 16.2 minus what? 0.1 m equals how much? So I am now 18. 1.8. See, you will not be getting everything, but some of you are already getting some things on your own. That's what is giving me joy. I can solve question on your own. Okay, I don't want to 10 now. Let's go. Number 11 to 20. 5 minutes. These are my timer now. Phone is not here. 250. Yeah, 11 to 20. No time. That solubility curve is not very, very clear, but you can still get some sense from the nonsense. On the left, it is 0, 1.0, not 10. Oh, that number 15, solubility. 0, 1.0, that's the vodka houses now. That's solubility per mole per dm. The vodka houses 0, 1.0, 2.0, and then 3.0 on the vertical. Zainab, are you okay? Okay. Well, be eating. The moment you don't eat. Khadija, I'm fine. Now when they talk for back, she's not doing anything, you see. See. First Corey not around. Okay. True by now. There's no calculation here. In fact, there's no calculation at all. Ire, you are true. Oriofe, are you true? Okoro, are you true? Oh yeah. Very true. Hello. Are you true? Yeah. Yes, it should be true by now. CJ, you are true. Akwa, you are true. Questions, you are true. Stand up. Let me see. Let's go. 11. Diagram above represent the formation of a. They brought two elements together. They can't join them, then they share electron. That's covalent, Abi. Then share. That's covalent bond. Some will say miss it too. They will be saying something again. Number 12. So the following statement is correct about the average kinetic energy of the molecules of the gas. Temperature is a measure of the average what? Kinetic energy. Doesn't have CRV. It increases with increase in temperature. The pollution from petroleum, you go miss this one. You never do pollution, so now what's work when I go they do. Let me see if you can get it. The pollution from petroleum spillage. That's a problem with Niger Delta area. The Shell, all of them, they come to that place, Mobile. They bring out petroleum from the soil, and then there's oil spills on our water in those areas, south of Nigeria. The water is no longer, good for drinking. The farmland, there's oil spill everywhere. And those guys, they gave money, $1 million to the what? To the kings and the people of the land, but they will just swallow it. Yeah, and people know all the people in that area. In fact, that place should be the most urbanized environment in the whole Nigeria. But unfortunately, they are still underdeveloped. That's why the Ogoni 7 came to complain, Kensarowiwa of his time, and they were fighting. They fought during the military era, and those guys were executed, then killed them, because some of the money actually go to Niger Delta Development Commission, and many of those guys, they don't use the money. The corruption is our problem. So there's oil spill everywhere. They now said, and we disperse those oil spill. Option A, pouring detergent. Option B, passing of sheep through the area. Yeah, sheep go past the area. Then when sheep pass like this, sorry, they all go. There's actually a method like that too. The sheep will go to that area, but the sheep have a way of taking care of the surface layer of the oil. Yes. All those 4 things that they give you, they are all correct. Yeah, for removal oil spill. But there's major one that we use. Foreign organic solvents, also correct. Now also is correct. Detergent can serve as what we call emulsifier, can remove the oil. The organic solvent can do the same thing. They can even apply evaporation, yes. They put fire on the surface, it will boil, and then it will go. But there's one major one that we use. Talk. Mastura. That's all of them are correct now. You got to pick them one by one until the right one go enter. Yes. C. Organic solvents. Yes. Detergents. Then solvents. Agents. We are going to say the same thing, so no need. Do anybody want to evaporate or want to pass ship? Yes, to be candid, all the four answers are correct. All of them. They are method of removing oil spill in a large area. But why we don't like that D is that by the time you apply it, maybe you put it, the material you're going to have will also produce another pollution. You're going to be having CO2, you're going to have CO. That's why that D is totally out of it. And then that's the passing of ship through the area also may not work because some areas may not be really habitable for those ships. Especially Nigerian ponds, the ship can even sink. So B may not really work. A and C are perfectly correct. I don't know the one Chan wants you to pick there because A, yeah, A, let's see. Agent is an emulsifier. It's going to remove all those things very clear. Solvent also is correct. It's going to dissolve the petroleum material because, listen to me, all those material, Mr. Correct, Amos has started teaching petroleum. Petroleum are gotten from what? Large decomposition of organic material over millions of years. And what can dissolve those things is organic solvent. Organic solvent. So if I want to pick answer, I'll go for C. I'll go for C. But as I've said, it is correct too. That's why I was quiet. That's why the question is a controversial question from JAMB. Controversial. It's already correct. But C is also correct. But if I'm to write the exam, I'll pick C. Zana, why are you picking C? Because organic solvent has the potential to dissolve anything organic, and anything inorganic, anything is not 1.5 now. Four. 1, 2, 3, 4, but you didn't draw the 4. If you look at that one very well, they are all 4, 4, 4, 4, 4. I mean, that 2.0 should have been higher than where it was. So it should have been 1.5. That 2 should have been 2 point later above. They didn't label it very well. That 2 should have been higher than where it was. So that should be 1.75 mole per DMK. Let's now go and get the reading at 25. What's the reading at 25? 0.75. 1, 2, 3, 4. 0.75. I will say 0.5. If the third one are at 20. If you miss it one mind, we are not doing exam or test, we just practice. But it's not very clear, that's why you are missing it. Just know how to get the value. At 25, the answer is about 0.75. Because of that, have you? The answer is 1. Fighting. Because it's not very clear. That's why. Never mind. 16. At what temperature are the solubility of L and K the same? The same. It's something I be 490, and that's the only one that is there. So and see another one we I go miss. Pure solvent are obtained by what? Condensation call Verstappen. Solvent are obtained by what? Distillation. Condensation. Which one will be condensation? So condensation is one of the separation techniques that you know. No, talk now. Separation techniques is condensation and separation techniques. The answer is simple distillation. We will pass it through iceberg condenser to now start dropping. Distillation. 18. What is the decrease in volume of air when pyrogalol is shaking with 30 cm of air? Now, what is the percentage of oxygen in air? Percentage of oxygen. 20.8, 21%, have we? 21%. So decrease in volume. Alkaline pyrogalol will take oxygen. So decrease in volume. Percentage will be 21 over what? How much is the volume of air? Let's see. 0, 0. That's why 6.3 have we? 6.3 cm cube. Again. 6.3. When are you people going to do acid base and salts? You don't know. What is Mr. Victor teaching? Metals, okay. Okay. They will teach you, don't worry. I'll tell them to speed it up. 19. But I have not done pollution, no. That's why we are missing all these small things. Environmental pollution. See another one we're not going to miss. Environmental pollution is worse thing. This of from automobile. You pick smoke, they're wrong. Heavy metals. Because they see car, they can't put smoke. Heavy metals. Yes, we call it lead poison. Smoke is CO2 and CO. Heavy metals, they are the lead poison. Say, that's why they always advise all those women who are selling akara on the road to cover it very well with nylon. So they are eating all those exposed bread on the road. They are endangering your life. Oh. All those suya on the road that you buy. Give me, make a taste. You taste suya for road, are we? That's heavy metal. Dangerous, oh, heavy metal. We call it lead poison. So that's not a D. I don't think that smoke one of you go pick. Most of you rather. 20. The chemical used for coagulation in water. If you are trying to coagulate, you have to use alum abi. And alum are made up of aluminum tetraoxo sulfate 6. That's the answer. Let's go 41 to 50. For 41. 50. We don't get time. This is 311. Before we start the physics now, before we finish by 6. Yeah, we should release those who are not hosted, Abi. That's why you can relate the students. I don't know if you are complaining, just return from holiday. I don't get bored. I don't get bored. That's all. I know. Have a big- But I want to 50, no time, 5 minutes. So now coupon, now what they do, they never teach organic. Oh, this thing, Amos mentioned it this morning. Oh. Yes, that's true. And I've seen two that he mentioned this morning. I think one, two self. Yeah. Are you true? Oh, yeah, yeah. Sure, Pluto cannot be back by now. It's in Shodun. Five seconds left. That's true. What's your name? Beside reading it to me. Mistiraj. Pardon? Speak louder. Imtiad. Imtiaj. Imtiaj. Ip, Ibtiaj. That's your name? Ibtiaj. Let me talk now. I will. Ibtiaj. Spell it. IPIBTIHAA. Okay. Ibtiaj. Okay. That's nice. You guys have a nice name. I've not heard that before. There's one name like that, Sule Kain or something. Sule Kain. Sule Kain. So many fine names in Adams College. Timothy Shakur. Seconds left. Some years ago in Adams College, one boy, his name is Ngozi. The boy, yes. I was asking, and that was true. He finished from Unibank. I said, why are you in concern? My mother was going for girls. He didn't have any girls. So maybe she named me. Yes, Ngozi, yes. I can't lie to you. That's his name. He never wanted girls. You didn't get girls. So when the boy came, he said, your name is Ngozi. That was his name in Adams. Okay, 41. Oh, maybe. I'm Bedo. Chlorine is spiral into water. See, we have done this one many times. Chlorine into water. Last week, we mentioned bromine water. We also mentioned chlorine water. So if you miss it now, then something is wrong with you. We've been talking about this for long. Chlorine pass into water. We've been doing it, so you don't put your mind. That's the problem. We play in class. HOCl and HCl. No, so that's the nitrogen. Oxygen, okay, and then exposed to sunlight. You can't expose them. So this one would now break down to HCl and oxygen. Have you? That's the answer. Chlorine, hydrochloric acid, and oxygen. That's an D. So please. Say in acid solution, undergo hydrolysis. That's the answer. And then write it down somewhere. Hydrolysis of protein gives amino acid. That's the answer. Hydrolysis of protein gives amino what? Acid. What of hydrolysis of glucose? What does it give? Hydrolysis of starch. What does it give? Glucose. Hydrolysis of starch gives glucose. Hydrolysis of sucrose. What does it give? Yeah, hydrolysis of sucrose gives glucose and fructose. Gives glucose and fructose. Glucose and fructose. Hydrolysis of maltose, what does it give? Glucose and glucose. Hydrolysis of maltose gives, going to say glucose and glucose, now glucose. Then lastly, hydrolysis of what? Lactose gives what? Very good. So hydrolysis of protein gives amino acid. Hydrolysis of starch gives glucose. We move. 43. A catalytic reaction of the compound class CnH2n belong to what homologous series? Alkane. And if you are alkane, you must undergo what? Addition reaction. Addition reaction. And if there's no addition, then polymerization. Answer is B. Addition. Catalytic reaction. So the major one you go is addition reaction. But if there is nothing there, then I go to polymerization. For example, the first member of that family is ethene. Ethene will undergo polymerization and give us what? Polyethene. Polyethene. Propene will also give us polypropene, like that. So the answer is polymerization. The pair of organic compounds are isomers. I've taught you how to do that. When you have benzene, see benzene. Benzene is like this. I need to start drawing. That's benzene. When you have methylbenzene, Mr. has taught you methylbenzene is toluene. Have you? Tolu. So this is methylbenzene. Can't be isomers. Why, sir? Because we are different compound. You do get CH3 for your head. Me, I get CH3. So we are not isomers. Option B, trichloromethane. Now, when you get trichloromethane, how many chlorine is there? You can't get tetrachloromethane. How many chlorine is there? Are you the same thing? No, we can't be isomer. You will get 3 chlorine. Me, I get 4. We are not isomer. Then C, ethanol. How many carbon is that? No, how many carbon? Three. Three. So you cannot be. So the answer is D. Both one in and what? Both two. For carbon atom, the position of the double bond vary. A burning candle, anything organic, once you burn them, I don't have CO2 and water. So a burning candle produces water and carbon dioxide. B. The gas that can bear the collected like look at what displacement of air. That's upward delivery. So yeah, but it's less than air. Ammonia, the vapor density is 7.14. Are we 14, 17? That's 8.5, less than 14.4. So that's ammonia. I know. Which one is now big? Vapor density of ammonia is 8.5. You have to divide by 2. That 17 is the molar mass. Governor, you're reading too much. 47. Following letters, I'm not sure this class is speaker is working. Speaker is not working. But I hear. What it's on is important thing. Following letters, once jump on yellow. Very good. So this one number 48, Mr. Amos taught you. I had the one who was mentioning that in the engineering class. And I've also written for you before. In you can see what you have speak to go XP. That's a class. Study. So close. As in heavy water molecule. The point of the so what is the function of the ocean? So what's the answer? The alterating agent. The guy remove water. Once you don't know with water, can you see Mr. Victor has taught you? So all your notes, read them. I said it in the morning. Listen to me. It will be advanced foolishness for a boy and a girl or a girl not to read this month. It will be foolishness. It will be very strange for us to start running out. Why are you using phone? Why are you not reading? No. It will be foolishness for somebody to be sleeping during prep now or playing when your exam is here. So nobody will be asking you, go and read. Or Adam's carrying cane during prep. Me, God forbid. So it will be foolishness for someone to be playing during prep or be not reading. Whatever reading is not reading. So I'm tired. I have cramps. I'm not feeling fine. And for the past 5 days, you've been feeling fine. You know? So don't be out with water. Something. Look at that. Water, H2O. Sodium is very, very inactive, isn't it? That's why we always keep our sodium below oil with paraffin oil. We hide it. Leave it in air. That will pick water. Only water, say, pick oxygen first, not the sodium oxide. Make sure, not the sodium hydroxide, and like that, pick carbon dioxide, not the sodium carbonate, like so on and so forth. Very, very reactive. So that way, you put it in water, it start darting around the surface of the water. Sound will be produced. Why? That will go to sodium hydroxide and release what? Hydrogen gas. So the answer is alkaline. Alkaline D. Let's go to the last part. 21 to 30 quickly. Akindia is not back. Okay, around. Ashinawa. Okay. Okay, let's quickly go through. Phosphorus is stored under water. Going from dehydrating, the guy don't get water. You want to some option doesn't make sense. You store it under water. We are exposing it to water again. Smelling, becoming the answer is D. Phosphorus is to catch fire at 30 degrees Celsius. So you have to store it under the water to prevent from catching fire. The answer is D. Usually the following reaction does reduction. What is reduction? Electron is gain or loss. Electron gain is reduction. So the answer is D also. I mean, is losing. See, minus. When you subtract from it, you are losing. So when you have minus like that, A, they are subtracting from it. So that's loss. C, they are subtracting, that's loss. D, they are adding to you are gaining. Reduction is electron gain. So the following will increase the yield of R. Want to increase R, will increase the yield of R. And the reaction is exothermic. Want the reaction to go to the front, Abby? So using a larger closed vessel, no. Increasing temperature, no. Because exothermic. Removing some S, yes. The answer is C. Now, if we add catalysts, what will happen? That will equilibrium to the front. You know, I won't consider D because this is talking about equilibrium system, and catalyst does not affect equilibrium. So we'll just pick C. If we remove S, equilibrium will go forward. The more of R will be produced. So the answer should be C. But if it is not a reversible reaction, then catalyst will have been an ideal answer. Or to lower the actual energy. So the answer is C. If iron displaces zinc from zinc chloride solution, this should have M is more electropositive than zinc. Okay? The answer is C. M can react more than zinc. Okay. On 25, should following explain the increase in the rate of chemical reaction. Now, for a reaction to occur, certain conditions must be met. Number one, there must be effective collision. Number two, you must surmount the activation energy. That's the major reason for a reaction to occur. So the following best explain the increase in the rate of reaction as the temperature rises. A, the bonds in the reaction molecules are more readily broken when it rises. That sounds correct. Let's go on. B, molecular coalition become more violent. That is more correct than A. So a lower proportion of the molecule has the molecule has the necessary energy to react. That lower proportion is not good enough. Higher proportion. The collision frequency of the molecules increases. That's correct. So let me see the appropriate answer. I can see three answers that are very correct here. A makes sense, B makes sense, D makes sense, even C makes sense, but that one lower is what makes it wrong. I'll see the correct one. Let's explain the increase in the rate of a chemical reaction as temperature rises. A, the bonds in the reacting molecules are more readily broken. There must be a bond breaking before bond making. The molecular collisions become more violent. Molecular collision. Collision frequency of the molecule, that's the D. The collision frequency, so why frequency? Talking about rates. Rate at which they are colliding now increases. So that's a D. 6. What current in amperes will deposit? Nobody should be implementing on current electrolysis. M is AIT by AF. So we're going to have AIT equals MEF. Does AIT still exist? AIT TV, is it still existing? Well, I'm still watching it. So I have 8C. I think mass now 27. E na 3 aluminium. Say 500. What is A? 27. Okay, it's one time. Sorry. I'll give us one time. How much? 2.7, 27. What time? 2,360. Finance, what do you get? 4 amperes. Ethanoic acid. Our ethanoic acid is this one, CH3, COH. The gas with nitrogen. Don't go and say tetra, the answer is monobasic. Mono. Say tribasic, get 3. We know they count this one. This one is methyl. Monobasic. It has only one replaceable hydrogen ion. Monobasic. Carbon plus 2 sulfur gave us carbon 4 sulfide. Delta H plus 89. The equation above implies that carbon and sulfur has 89 kilojoule of energy. Okay, that's the heat of formation. No, it is wrong. It doesn't make sense. Both carbon and sulfur contribute 89 kilojoule of energy. No. 89 kilojoule of energy is absorbed. Have you? That is what? Endothermic reaction. 29. Equilibrium constants. What factor affects equilibrium constants? Temperature only. The reaction is exothermic or endothermic. So, the equilibrium constant for the reaction above is increased by well, we don't speak increasing temperature, but that's not the answer. I hope we all know. But it's exothermic reaction, no. But that's the only thing that affects it. You just speak temperature like that. For example, if you see something like just speak temperature, don't even bother yourself, you and move away. But if you don't have increasing the temperature, decreasing the temperature, that bill will have been ideal one. Because it's exothermic. The reason why I pick that because they may make a mistake, it may be endothermic in the question. Maybe when they are strengthening, they made a mistake. So just pick A, don't argue. The only temperature that affects equilibrium constant. Let's see. Plus, on the left, that ordinary copper. What is the oxidation number of ordinary copper? Zero. Now become what? Copper 2. This copper 2. So how do you know this copper 2 nitrates? So they are from 0 to 2. They have been oxidized. Therefore, like what? Reducing agent. Reducing agent. Because once again, I wish you all the best in the month of April. Hope to see you tomorrow. Well, yeah. The reason I'm releasing is not because I'm tired. I have class by 4. That's why. And you start now, won't finish. I have the afternoon classes 4 p.m. So that's the only reason. Not because I want to release you.
Just this video right